Hello class, today we're going to be looking at some special triangles to continue our discussion. We already know that what type of triangles equilateral triangles are and isosceles triangles. By the name equilateral, we know that all the sides are congruent. But in an equilateral triangle, not only are all the sides congruent, but also all the angles are congruent. And not only are all the angles congruent in an equilateral triangle, in order for all the angles to be congruent and still the sum of the triangles interior angles is 180, that means each angle must measure 60 degrees. And so this is one added property of equilateral triangles. Then let's take a look at an isosceles triangle. And here we have some new vocabulary. We know an isosceles triangle, we know that that means that there are exactly two legs that are congruent. And we call these sides legs of a triangle. And these are the sides of the isosceles triangles that are congruent. Okay, we do have a third side, but we don't call it a leg because it's not congruent with any other side. So in an isosceles triangle, the legs are the sides that are congruent. And then we have angles, because not only are legs congruent, but two sides congruent, but we also have that two angles are congruent in an isosceles triangle. Well, these two angles are called the base angles. And they are the angles that a side makes with a leg. The side makes with the leg. So there's only two of these base angles. Then there's a vertex angle, which is an angle that is formed by the two legs of an isosceles triangle. So I know this is a lot of vocabulary. This is a good visual, which I suggest you draw in the notes. And let's take a look at the notes on page 85. In the notes on page 85, we've defined what the legs of an isosceles triangle are, what the vertex angle is, what the base, which is the side of the isosceles triangle that is not a leg, and what the base angles are. Okay, so if you're unfamiliar with the terminology, make sure you take a look at the note. Further on down the notes, we see we have some theorems about the base angles. And a lot of times you may see the book identify a triangle as isosceles, or sometimes they won't even say it's isosceles. But we know if two sides are congruent, that we know if it's isosceles. But one of the theorems is if two sides are congruent, then that means that two of the angles are congruent, and those two angles in this picture that are congruent are B and C. And we know that conversely, if two angles of a triangle are congruent, and they haven't said isosceles, but we know it's an isosceles triangle, because if two of the angles are congruent, that means two of the opposite sides are congruent, which means since angle B and C measure to be the same angle measurement, that means the side opposite them should also measure the same. So AB is going to be congruent to AC. Okay, pretty obvious, but it's important to have these noted. And if you notice, they haven't said anything about isosceles triangles, but both of these are isosceles triangles because we can show that each triangle has exactly two sides that are congruent. Now let's take a look at a theorem about an equilateral triangle. If a triangle is equilateral, not only are all the sides congruent, then that means all the angles are congruent, and we call a shape where all the angles are congruent equiangular. So in this case, if a triangle is equiangular, which means all the angles are congruent, then that means that it's also equilateral, because an equilateral triangle has the special properties that all the angles are congruent. And if you note, this is the indication that all the sides are congruent, the little hash mark, and this is the indication that all the angles are congruent. They both have the same type of arc. Okay, I want to talk about something that's not in your notes, but it's something that you did in middle school, which is lines of symmetry. And we say a figure has a line of symmetry if it can be folded exactly over onto itself. And that fold line, where it folds exactly onto itself, is called the line of symmetry. So let's take a look at some triangles, and equilateral and isosceles triangles. So here we have an isosceles triangle, and we know it's isosceles because it has two sides that are congruent, or we know it's isosceles because it has two angles that are congruent. Well, an isosceles triangle has only one line of symmetry, and that's through the vertex angle. And then, and if we were to fold this triangle over this fold line, then this side would map entirely onto this side. So an isosceles triangle only has one line of symmetry. But how many lines do you think an equilateral triangle has? Okay, well, an equilateral triangle actually has 3 lines of symmetry. And each of those lines go through the vertex. And they go through the vertex in such a way that they bisect the angles, and then they bisect the sides. And bisect means to cut into 2 congruent pieces. Bisect is, again, it's a very important word in geometry. It means to separate into 2 congruent pieces. So this line of symmetry separates this angle into 2 congruent pieces. And these 2 congruent pieces are, this piece is one and this piece. Okay, so the lines of symmetry of an equilateral triangle will bisect each of the angles, and not only will it bisect the angles, it will also bisect the sides, because these will actually intersect at the midpoint of the sides. Okay, I know a lot of vocabulary, but most of it is easy to understand if you see the picture. So I strongly suggest you copy down these pictures in your notes on page 85. And the last thing we want to talk about is the midsegment of a triangle. And by definition, a midsegment is a segment that contains the midpoints of 2 sides of a triangle. So if this is one side of the triangle, and this is the midpoint because it's the middle of this side, and this is a midpoint because it's the middle of this side, and this is a midpoint because it's the middle of this side. And a midsegment is a line segment that connects the 2 midpoints of a triangle. So in this triangle, we actually have 3 different midsegments. Here's one midsegment because it connects these 2 midpoints. Here's another midsegment. It's a midsegment, it connects these 2 points. And here's another midsegment, it connects these 2 midpoints. And we know they're midpoints because it breaks each side into 2 congruent pieces. So the notes on page 85 define a midsegment of a triangle, and we're not going to spend a lot of time on it yet. Later on in the semester we will talk about it. But there is a property that some of us discovered in class yesterday, which is that the segment containing the midpoints of 2 sides of a triangle is, what's the relationship? It's going to be parallel to the 3rd side of the triangle. As you can see, these 2 parallel symbols, and the relationship between the length of this midsegment and the length of this side is the midsegment is half as long as that side. So if this side AC was 12, then this side would be 6. Okay, that's it.